Okay, this is Mr. Flores, showing you how to check your work by using a method I call eliminating nines. Today we're going to learn how to check addition. Using the traditional method, what we would do is we would use the inverse of addition to check our answer. Let's go with this example problem. We have 6,891 plus 2,452. Go ahead, try to solve it. Okay, the answer is 9,343. I know you were able to solve it that fast. Even if you weren't, don't worry about it. You'll get quick later on. By using the traditional method, what we would do is we would take our 9,343 and we would write a new problem, but this time it would be a subtraction problem. Subtraction being the inverse of addition. We would take 9,343 and subtract one of the addends. In this case, we'll subtract the middle addend, or the second addend in this case. And hopefully, when we subtract correctly, we end up with a difference that matches our first addend in the original problem. So if we have 6,891 here and 6,891 there, then we can be assured that our answer is correct if we did all of our addition and our subtraction part correct. What I like to do is I like to use the eliminating nines method to check very quickly for wrong answers. Notice that I say we're checking for wrong answers, because if it's wrong, we want to do it again. Using the same problem that we had before, what I would do is I would eliminate nines. Looking in the first addend, I see a 9. I would cross it out. I would also cross out the 8 and the 1 because those add up to 9. And that leaves me a 6. In the second addend, I would cross out the 5, the 2, and the 2 because all of those together add up to 9. And that gives me my two check numbers. I have a 6 for the first addend. I have a 4 for the second addend. I would add those two together, and that makes 10. I don't like two-digit numbers. I don't like multi-digit numbers, so I'm going to add the digits together. 1 plus 0 makes 1, and that is my checksum. I'm looking for that when I check my the sum of my original problem. So looking at the sum of my original problem, 9,343, I see that there's a 9. I'm going to cross that out. There are no more 9s, so I add up the remaining digits. 3 plus 4 plus 3 equals 10. The 1 and the 0, multi-digit number, don't like it. Going to add those two together. 1 plus 0 equals 1. And then what I look at is I check to see if my check digit, or checksum, is matching the check number for my original sum. If they do match, then I'm pretty sure that this answer is correct. I'm going to leave it alone and move on. Okay, it's probably correct, so I'm going to leave it alone. If it didn't match, then I would redo the problem again to see if I can get the correct answer the second time. So eliminating nines is the main method that we're going to use, and that's the one we kind of have to understand. Let's take a look at this number 237. If I wanted to eliminate the nines, that means I'm going to get rid of nines. I could do it this way. I could subtract 9 over and over and over and over and over again until I don't have any more to subtract. That would leave me with 3 left over after I subtracted everything. We could also do division because, as you know, or maybe as you don't know, you will learn that division is just repeated subtraction. We could divide 237 by 9, which gives us 26 whole and a remainder of 3. In both cases, we have 3 left over, and 3 happens to be our check number for 237. So this is how you get check numbers, is you can eliminate nines, because who wants to subtract 9 26 times? And personally, I don't even like doing long division to come up with the remainder to check that. So there's a really easy, neat trick. It only works with nines. This is how you do it. Take the number 237. You see there's a 2 and a 7. 2 plus 7 is 9. Cross those out. There's our remainder of 3. That's our check number. Take a look at this number, 4,345. Do you see any 9s in there? Yep. 4 plus 5 is 9. When I cross those out, then I have those two remaining digits. I just add those together. 4 plus 3 is 7. My check number for this number is 7. The same way, sometimes we're going to go through all these. Sometimes it happens that we have two sets of 9. For example, we have 1 and 8, and we have 2 and 7. Well, we've crossed out all the numbers. Nothing's left. Nothing is represented by 0. So 0 is our check number for 1,287. In the number 19, this one's too easy. Do you see a 9? Yep, cross it out. That leaves us with a 1. 1 is our check number. In this number, 23,586, it's going to be a little bit more complicated because what happens is when we add all of those digits up, well, actually, first let's get rid of the 6 and the 3. We can cross those out because that makes 9. Then we add up the 2, the 5, and the 8. That gives us 15. We don't like two-digit numbers just because it makes it easier when we have one-digit numbers, right? So let's add the 1 and the 5, eliminate 9s again. The 1 plus 5 equals 6. So 6 is our check number for 23,586. That's how you eliminate 9s. Now to check our addition, there are only 4 steps. Once you know how to eliminate 9, it becomes really easy. First, you need to find the check numbers for each addend. The second step is to add the check numbers, and that gives us something that's called a checksum. Then we're going to find the check number for our answer, the answer that we're checking to see if it's right or not, and we're going to compare those two numbers. If they match, then our answer is probably correct. We're going to leave it alone and move on to the next problem. We're only looking for the wrong answers, the ones that are definitely wrong that we should redo. We don't want to spend too much time going over the same problem again and again and again if it is right. But if it's wrong, we want to have the opportunity to fix it. That's what this does. It gives us the opportunity to fix our mistakes. So let's go through these steps using an actual problem. Here is 1,234 plus 970. We're looking to see if our answer, 2,204, is the correct answer, or if it's wrong, then we can fix it. So here are the steps. First, we need to find the check numbers for each addend. In the first addend, we're going to cross off any 9s that we see. I see a 4, a 3, and a 2. 4 plus 3 is 7, plus 2 is 9, so I'm going to cross those guys off. In the second addend, I see the 9. I'm going to cross that guy off. And that gives me a 1 and a 7, 7 plus 0, for my two check numbers. The second step says add the check numbers to get a checksum. 1 plus 7 is 8. That one's super easy. I can do it in my head. Then I need to find the check number for my answer. My answer is 2,204. I look for 9s. I don't see any 9s, so I'm just going to add all the digits up. I have 2 plus 2 plus 0 plus 4, and that gives me 8. Now I'm going to compare them. My check number for my sum is 8. My check sum over off to on the top is 8. They both match, so my answer is probably correct. I'm going to leave it alone, move on to the next problem. Now let's do the same steps. We're going to use a different example because sometimes it's a little bit more complicated when our check number ends up having more than one digit. Again, first step is to find the check numbers for each addend. If you look at our first addend, you can see that we have 6 and 3, which is 9. We can cross those out. Now we would add the 6 plus the 5, the remaining 6 plus the 5, which make 11. 11 is a two-digit number. I don't like working with two-digit numbers usually, so what I would do is I would add the 6 and the 5, which gives me 11. I'm going to take the two digits in 11, 1 and 1, and add those two together, and that gives me a checksum of 2. Let me go through it again with the second addend here. 1,974. I see a 9. I'm going to cross it out. Now the remaining digits, there are no more 9s that we can make, so we add 1 plus 7 plus 4. That gives us 12. I don't like two-digit numbers, so I'm going to take the 1 and the 2 in the 12, the two digits there, and add them together, and that gives me 3. So my check number is 3. Now we can move on to the second step. I'm going to add the check numbers and get a checksum. 2 plus 3, 5. Easy, do it in my head. Now I'm going to go on to the next step. I'm going to find the check number for my answer. I see an 8, a 5, a 1, and a 0. Now if I'm being observant, I'm going to go, hey, 8 and 1, that makes 9. I can cross them out. That would leave me with a 5 and a 0, which my check number would be 5. But watch what happens if you accidentally forget to cross off the 9s. You just add the digits together anyway. 8 plus 5 plus 1 plus 0 is 14. Then you say to yourself, hey, I don't like two-digit numbers, so I'm going to add the 1 and the 4 together. That gives me a checksum of 5 anyway. Even if I had forgotten to cross off the 9s, when I add all the digits up, it's still going to give me the right checksum. Now I can go on to my to step number 4, and my answer matches my original checksum, so my answer is probably correct. I'm going to leave it alone and move on to the next one. Practice these steps over and over again. After you get used to them, you can start checking your work really, really quickly, and it makes it when you can do it very easily and quickly, then you start doing it more often because you want to get good scores on your grades. You want to get good test scores, or you just like being right, which I like being right. So I practice this a lot. It makes it really easy for me. Use it all the time. Okay? Good luck on your work.